Okay, so, all right. So maybe for a second you can just watch what I'm doing, and then maybe I'll give you a chance to do it on yours. So I've got a bunch of. So before I start something new, I like to clear my environment. I got a bunch of stuff I was working on. Maybe I'm gonna save it. You can save your environment and all the variables that you've created. So this will take a second. Okay, so then we're gonna load all these packages, and at the top of this script, there's so this here is a function definition. When you run it, you won't see anything happen, but basically it sets up this QQ dot line for you to be able to. Junior, can you mute? Your keyboard's really loud.
Sorry, I'll try.
And then so it's just a function, and I use the output directory to save all the stuff into. So this line asks, in R, an exclamation mark means not. So if the output directory exists, but not if the output directory does not exist, then create a directory called output. So I don't know where you've set up, where you've put your data. I have it in like this betaglucan directory.
And those are like the outputs that you wanted us to get, correct?
Well, these are the outputs that R is going to create, that we're going to make with R.
But like the set PW, the set WD, that's where we put like our outputs from Chime. I mean, right?
Well, I'm actually not exactly sure. We'll have to see. Well, so like right here, the first files we read. Yeah, we've set the directory to be where the data is stored.
Okay.
Okay, so my current environment finally got saved. I'm gonna wipe it now. Okay, so I'm gonna get started here. Again, on my computer, I use command return to run. That's a shortcut. You can hover. I can hover on this, and so that kind of like clover leaf and the arrow, that means command return. So instead of hitting the button, I use the keystroke command return. I'm gonna load all these packages. And I set my directory here. List files. So I've got all these files that I got from Natalie. betaglucan metadata. Okay, and then I'm going to run this function definition. So here it's listed as a function in the environment here. And okay, so we can see our files here. So we should see the an output directory be created. So here's the output directory that we just created. And so now we're going to read in. So now we're actually going to do something with these files that we got in. So we need our metadata. And in my case, the metadata is called betaglucan-metadata.tsv. And you can use tab, betaglucan. So I just hit tab. Betaglucan metadata separator is. So here this means that the separator is a tab, which in our file it is. Header equals true. That means we have a like column titles. Strings as. This strings as factors means strings are like words with letters in them and not numbers. And by default, if R sees a column that's all words, it formats it as a factor data type, and this is telling it not to. So we'll go ahead and sometimes factors are useful and sometimes they are not useful. So okay, so I ran that down here. There's no errors, so it looks like it loaded in, but we need to always when you read something in, you need to look at it to make sure it seems that R has recognized it like you want it to. So this str of metadata. So metadata is the thing we just read and created. And actually first we can just click on this and give a look at it. So we have metadata, we've got our diet, sex, and pen. We have this additional chime.
Wait, what did you click real quick to get there?
I just clicked right here on
Metadata
in the environment. So we really don't want that first line there, because that's chime stuff. Is there a chime to R feature for this? So we can delete that line, but I just want to see what the chime to R people say. Reading artifacts. Let's see what this function looks like. So this is using the chime to R package function, read chime to metadata. betaglucan.tsv. I should have named that something different. So their function removes that second header line, which is nice. I think that's the only difference. So they just skip. So I called my original line metadata 2. It has 60 observations. That's 60 lines. The other has 59 because it deleted that second header line. Other than that, they should look the same. Starts with Barrow 10, 11, 12. Yeah. And then, so maybe we'll use the chime to R function. Then this next line, line 59, it says str metadata. Str is, you might think of as the structure of the data. So if we run that line, we see that it tells us the data type for each column. So it's loaded everything in as factors. We have our sample IDs, and it has factor for each of the individuals. Diet, it says there's 5 levels, A, B, C, D, and there's an E, right? And then sex. So then, just to explain this a little bit more, so with these factors, it actually assigns levels. So A is level 1, B is level 2, C is level 3, and D is level 4. And then it actually then assigns and uses that index 1 through 5 as the values that it's kind of going off of. But that's not super important that you know that, but and then there's another thing you can do. What if we ask for metadata? So this diet, we see that there's 5 levels, but here they only display 4 of them for us. So if we wonder, what's the 5th diet level? We can ask for, so this is referring to the metadata data frame, and this is the diet column. And we can ask for the levels. So then it tells us the levels, A, B, C, D, E. Okay. Sometimes there's lots of levels, like the same thing for pen. It's listing them in a little bit different. It's going off. It's sorting them by the first number. It's kind of like more alphabetical order of numbers. So it's 1 through 30. Okay, so this is all not all that interesting. It's just looking at the metadata. So here I have some lines in here because this is from a different thing. From my other example, this is how you convert a column into a factor. So if you remember, the original code I told it strings not as factors. So some of the columns are imported as character type or like letters. And so then I converted them back into factors. So I'm going to leave this here as like an example of how you would do that, but in this case, the chime to R function loaded everything in as factors anyway, so we don't have to change anything. row names of metadata. So this line took the first. I took this column and then made this the row name. So right now the row names are 1, 2, 3, 4, 5. Our metadata also does not have row names, so we'll go ahead and use this. So this is what it looked.
Could you go to metadata real quick and scroll down to 14 for 1 second? I want to see if I'm the only one that's missing it.
14 what?
Okay. Yeah, I don't know why. For my 14, it's empty.
Oh, line 14?
Yeah.
Okay.
Can you sort by number real quick for me? Actually, it is sorted by number, right?
It's sorted by the sample ID. You can click these headers and it'll sort it. So we have Barrow 10, 11, 12, 13, 14, 15.
Some reason between Barrow 13 and Barrow 14, I have just an empty space. I sorted by the most left thingy. I guess I was using the old one metadata too.
Okay.
But
so also maybe remind me, guys. We only have 59 animals listed because what? Two of the, I think pin 25 was not used, and pin 15, 16, 17, 18, 19. There was another pin that was not used, right?
Did you guys?
Sorry, go ahead.
Go ahead. I was gonna ask if you guys.
Oh, I thought it was 25 Barrow and then like 18 Gilt, and then we definitely took out Gilt number 3. I know like it was like either 25 or 18. We like took out one of those two numbers.
Well, it looks like
I'm using an older one because I have 62 obs of 4 variables then.
So it looks like,
yeah, I think it sent you the one without Gilt 3 removed.
yeah, Gilt 3 is here, but it should be okay actually. So we don't have Barrow or Gilt 8 or Barrow or 825. I think those pins are empty, and then we don't have something else. 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 18.
Were you guys able to run the metadata to read Q2 metadata line, Tessa, Natalie?
I haven't. I've just been taking notes. I haven't done anything yet.
Oh, okay.
Sorry.
You're okay.
Okay.
Maybe I'll just. I don't know.
I'm gonna keep going. So this line is just gonna convert this here metadata. This is a way of selecting rows or columns. So this bracket, it's like a coordinate system, except so before the comma, there's nothing listed here, but this is to designate rows, and this after the comma is to designate columns. So in this way, it's nothing before the column. So that actually refers to all rows. If there's nothing listed, it assumes all rows. And it's taking the first column. So all rows from the first column. And that translates into take this sample ID. So it's going to use the sample IDs as row names. So if I run and it's the row names of metadata. So if we run that and we look back at metadata again, so now we have those sample IDs as row names here. Okay. And metadata sample ID. So let's go ahead and take off the comment here. On line 66, we're going to delete this is going to delete the first. Since there's a minus here, it's going to erase it. This is since we have it's now repeated. It's the row name and sample ID, so we can delete this column by using this -1. So now our metadata has the animal ID as the row name, and the column headers are there. So it's kind of nicely formatted now. And we're not going to use this. You could use this to look at what your sample ID. Oh, we don't have that column anymore.
This might be a dumb question, but why did we want to remove the first column of sample ID and make it into a row?
It just makes some things work better later.
Okay.
Some functions assume that you have row names that are the sample names, so it's a fair question, and I don't know. It just something. Most things just run nicer if you have them as the row names. So you can ask what the row names are, and it'll list out all the row names that we just created. This taxonomy.tsv. So we didn't do this step yet. Taxonomy.tsv. We have taxonomy.qza.
I have a question.
Yeah.
How did we get rid of the top line on the metadata, the like categorical?
We got rid of that by using the chime to R metadata function.
Oh, okay.
So this function knows that chime uses that second, kind of like a second header line, and it deleted it.
Okay.
You could also do that this way. So we just deleted the first column here. So could you imagine how you might delete the first row?
The -1 would be before the comma, right?
Yeah. So if we went back and used our metadata 2, it has that thing there, that second header line. So if we type metadata 2, and I'm just, maybe I'll just copy this. And we just change the comma. This should delete the first row. All of the columns from the first row. Oh wait, oh shoot. I need this to be metadata 2. Now I've messed up metadata. We'll have to do it again. So metadata 2, so now that second header is gone. Okay.
Thank you.
Okay. So we're going to skip this taxonomy section here from line 70 to 85 for now, because we're not going to use it for a while. And then, so our first thing we're going to do is to make a PCOA graph, Bray-Curtis. So we have Bray-Curtis PCOA results. We don't have a core metrics results directory, so we're going to delete this. And run that. So it ran down here, we got no error. These are 2 lines that I use for corn. What do I use these for? So right now we'll just skip this. And so this block here, 90 to 92, is to join together this Bray-Curtis. So we created this thing, Bray-Curtis PCOA variable, and we're going to join that together with our metadata to enable us to make a figure more easily. Now this Bray-Curtis PCOA object is not just a single data frame, so we have to use this. These are elements within PCOA. So there's underneath PCOA there's an element called data. So we can look at this a little bit. It's a list of 7 items. The 7 items are the ones listed here in the leftmost. So we have this thing called UUID, a type, a format, contents. Eventually there's going to be a data. So here's the data. And then underneath that there's a vectors. Here's the vectors. And that's going to be all the coordinates of all the samples. So we can look at we're going to assign this to a new thing called Bray-Curtis meta. If we just look at what, you might wonder, well, what is this PCOA data vectors thing? You can run just this item to see what that looks like. You have to scroll up to see it. So it lists all the samples and all of the principal coordinates. PC1, PC2, PC3, PC4. And this is essentially the X, Y, and Z axes. So when Chime makes a 3-dimensional graph, they're using principal coordinate 1, 2, and 3. And then the next line is going to select, we just want to work with PC1 and PC2 and the sample IDs. So it's basically going to pull out the first 3 columns out of that, and it's going to join it together with the metadata. And sample IDs. So here, this is the column name in our metadata, and I think it's different. We don't even have a metadata.
Why is everything below your 87 just blank?
87? In my code?
I think I'm lagging, maybe.
You say line 87 in my code window?
On your code. It was. Oh, I think it's just internet. My bad.
You see it now?
Yeah.
Because right now I'm talking about lines 90 to 92.
Yeah, I was like confused because it wasn't there.
So I'm not sure if this is gonna work. So this is one case where, let's run it and see what happens. I think I'm gonna get an error. Yep. There's no column called sample.id in our metadata. Let's see what happens if I just delete this. Nope. Let's see what happens if I put a 0 here. We want to match it to the row names. Nope. Okay, so we're gonna go back up here and not delete the names. So I'm gonna run this metadata again, because I want to get that column back. We are not gonna delete this. So we have our sample IDs as both the row name and this column, sample ID. Because we need to tell the thing what column to match. So what this is telling it to do is if we run just this much, we have this BC meta data frame, and it has sample IDs and principal component 1 and 2. Right? And the next line is it's asking to join these 3 columns with our metadata columns, and to put them together based on a column, a shared column, which is the sample ID. So we want all the metadata for Barrow 1 to be right in the same line with its principal component. And so that line of code says take Barrow 1 from this one and Barrow 1 from the metadata and put them on the same line. And so when we do that, now we have Barrow 1, the coordinates, and then also the metadata for that individual. And we have that for all of them. Okay. So then from there, we're pretty well set up to start making a graph. My column. So I use this variable called myColumn throughout the code. So we're going to go ahead and continue using it. And this is the thing that we're interested in. Get my column. I have to remind myself what this means. So let's look at the diet. We're gonna Okay, so I had to remind myself a little bit what this was going to do. So the goal of this line is to determine the center of each group. So it's going to aggregate PC. So it's going to end up using PC1 and PC2, but it's going to group things by this myColumn variable, which is the diet factor. And this is, each of these things have a each of these, this seems kind of like random, but each of these positions is talking about a specific thing. We can get the help on aggregate. This is a dplyr. Maybe it's stats. So this, sometimes these help menus aren't very helpful. So these are the things we want to keep. This is what we're grouping by. This is the input data frame, and this is the function. We're going to calculate the mean. So basically, it's taking all of the group A's, and this is the average value of all of their PC1s, and this is their average value for PC2s, and the same thing for each of the different treatment groups. So you're going to see in a second what this is useful for. So now we're going to make our first PCA graph with ggplot. This is the data, the input data, and then there's this AES parenthetical statement here. So the x values are PC1. No, so this is an XY scatter plot. X is PC1 and Y is PC2, and we're going to color according to the diet treatment. Again, this is the myColumn variable up here. And we're going to make this into a geom point, which is meaning a dot plot. So we can run these first two lines to see what this would look like. It's thinking about it. Okay, so here in our plots tab over in this lower column, here's our graph that we just made. So it's a different color for each treatment. So that's what this right here, color equals get myColumn. That's what assigned each diet treatment to be a different color. And as we've seen before, they're just all kind of mixed together. We have PC1. So here this x equals PC1, that assigns PC1 to the x-axis, so it's here. PC2 on the y-axis. And that's what we've done so far. If we run the next, if we add in the next layer, it's going to change the theme of the graph, or the colors. So they advocate for this different. They're going to take away the grid lines, I think. Takes a second to run. So that's our old one. Where's our new one? I don't know why our graph isn't showing it. Okay, let's keep going. So the next line, I really don't know why that didn't work. Let's add in this. So I have this line commented out. Let's see what this. So this is using our centroids. It's adding in a new. It's going to use this centroids thing that we created up here. I don't highlight the plus because I'm stopping in the middle of this block. If you highlight the plus, it's going to expect more code to come after it. So I'm highlighting everything except the plus to kind of just run part of it. Diet not found. Okay. It might be because this centroids data frame, it doesn't have, this should be diet. So we can tell that to become diet. So we want the row name of centroids. The first column. Let's see what it is. No. Column name. Yeah. So the column. So I'm going to reassign the column name to be diet. So this is the first column. So this is the selecting the first element. So let me back up a second. So the column names, I'm down here in the console. The column names of the centroids data frame are these things. Get my column PC1, PC2. That's the same thing we see when we click on it, right? We don't want to change all of these. We just want to change this one to say diet. So when I run this is just talking about the first element in this list, which is this one. So we run this line, and instead of giving us all the column names, it just gives us the first one. And then when we run this line, it's going to assign now diet to be that name instead of this get my column business. So now if we run call names of centroids again, it didn't change. Why didn't it change? Did I change it? Okay. Now I Google it. Okay, I have a slightly different order. I'm supposed to put the bracket on the outside. Okay, that changed it. So I don't memorize everything. Google is your friend. So it just goes to show you that even that I have been doing it for a couple of years, I still have to use Google. So let's see if that fixed our issue here. And I know, Junior, you have to go to class, right, at 9:30 or 10:30?
Yeah, so I'll pop out when it gets closer to 10:30 or something.
This thing is still... I don't know why it's not...
It's online anyway, so just hop into another call.
Okay. So I skipped down. I ran line 107 to save the picture. Let's see if it showed up in our directory. Betaglucan, data from output. Okay, it's here. Sometimes things don't show up in this window. I'm not sure I can tell you why. Oh, now it's showing up. So these bigger dots are the center of each of these clouds of points. So here's the center of group E, group A, B, C, D, E. So the centers of all these are pretty close, and the data are all spread out. So it's hard to have statistical significance when they're all so close. So what are these other lines? This line here draws an ellipse around each of the treatment groups. This one is going to change our X label, and it's going to add in the proportion of the data explained, like the chime graphs usually have. And this is going to do the same thing for the Y label. This one is to change the colors. We don't need to change the colors. So let's run all of these lines together. And then it's saving it as BC ellipse. Putting in the my column, which is diet. So it's the Bray Curtis with the ellipse for the diets. It showed up here. So now we have our percent of the data explained here and the axes labels too. And then we can run this line to save it to our computer. This is our old one. And this is our new one. So these ellipses are really big. They surround much more than just the data points. So there's a different function. This is the quick and easy way to draw these circles. But these circles are pretty big. So as we've seen before, there's not a lot of differences in any of the data, right? So that's our first one. And then what I think I do a couple of more and I change certain aspects. Is there anything that we'd like to? So like in this one, I changed according to a different column, the litter treatment. Is there any other column that we'd like to show up in our data? We could include sex as like a shape. So here we can change this to sex. Is it uppercase, lowercase? Everything else is the same. I'm just going to delete this plus here. It's taking a little while to think about this. So this line's gonna save that with add in a dash sex so that we have a different file. So here's our new one. So now females are circles and males are triangles. And they don't really, they're pretty well all mixed together. Those ellipses are really distracting. So you can edit different parameters to try to create the graph that you want. Like we might not include the ellipses. And so that's where we're probably going to stop today. I think you can try to run your code up to that same point and try to create it on your computer. And then there's very similar code for this is the weighted unifrac. So we have different beta diversity measures, right? First is the Bray-Curtis. This is weighted unifrac. And it's essentially the same thing again. So if you could run those two things, the taxa bar plot, let's see here, taxonomy. So how about you just try to create the Bray-Curtis and the weighted unifrac PCOAs and start with that and see if you can create those two groups of figures.
Are you going to be able to send this video to us?
Yeah.